The James Webb Space Telescope has now shown us 15 galaxies that existed before the Big Bang, and the search for the oldest galaxies in the universe seems to be underway. Since its launch, the telescope continues to surprise us with new discoveries and sensations. The world of science is in awe, and new explanations are needed. With James Webb, it's never boring. This telescope is a marvel of technology and a revolution in the natural sciences. 15 galaxies, beautifully crafted and appearing older than the universe itself, not only set distance records, but also cast doubt on the general models of galaxy evolution in the early universe. Since the summer of 2022, reports of impossible galaxies have been pouring in, leaving science bewildered. The Webb mission is just beginning, and the new super telescope has provided us with only one image of the early universe so far. They will continue, and soon we may find ourselves speechless before even more incredible phenomena. Did you believe that our universe is 13.8 billion years old and originated from a massive explosion? Although the theories were consistent, doubts have always remained. Recent evidence of inconsistencies, expansion, incorrect interpretations of distances, and corrections to the age of the universe have emerged. James Webb only intensifies the discussion that began long ago. Thanks to all improving technologies, it seems we may have been able to understand the age of the universe more reliably. But those who have been paying close attention have also found evidence that scientists are guessing more than they know. The age of the universe has been revised 3 times, until we arrived at the current 13.8 billion years. And now Webb shows us that this too may be incorrect. The central theme in the discussion of the true age of the universe and the distance to galaxies has always been the phenomenon of redshift. Redshift refers to the elongation of light waves to longer, reddish values. Values are usually interpreted as a measure of the speed at which a galaxy is moving away from us. The greater the redshift, the faster the movement, and the farther the galaxy. This observation has long been one of the key pillars of the theory of an expanding universe, but now this redshift, of all things, is being put to the test. Perhaps it has been misunderstood from the very beginning. We do not know how dust, gas, and other interstellar matter can affect light on its way to us, leading to color values that we may be misinterpreting. About 100 years ago, Swiss physicist Fritz Zwicky suggested that light undergoes changes as it travels through space, causing minimal fatigue. Zwicky's theory more accurately asserts that redshift is not caused by the expansion of the universe, but by the interaction of light with matter or radiation fields in space, leading to the loss of light energy and its redshift. In simple terms, this means that the source and the observer are not moving relative to each other, which means that the idea of expansion is incorrect. What does this mean in practice? The question can be answered in several interesting ways. First, it would mean that space is not expanding from a starting point. It would also mean that the idea of the Big Bang would be incorrect, and along with it, the idea of how the universe will end one day. Here before us stands a new reality, brought about by excessive speculation, the Big Rift, then there's the Big Freeze, predicting that expansion will ultimately deprive the universe of all its energy, causing it to freeze. And, of course, there's the Big Crunch, which tells us about some finite catastrophic point. But what if there's no expansion? Then we might live in an infinite universe, in a bubble universe, or even in a 12-dimensional universe, part of which we can only describe very insignificantly with our current physical knowledge. This raises an intriguing question. Will we ever be able to know the true age or size of the universe currently? We're not sure if we can succeed in this. Perhaps new areas and new surprises will emerge, and we may never be able to definitively determine the beginning and end of our investigations. Just imagine, only 500 or 600 years ago, people believed the Earth was flat. Then even astronomers thought the sun revolved around the Earth, and today, we gaze into the incredible 13 billion light-years in space, which never ends and again astonishes us with entirely new phenomena. Those seeking reliable explanations and evidence will be disappointed, but those who appreciate the new and mysterious will gain plenty of new insights from James Webb. Rendra Gupta, a Canadian researcher, proposed a theory in the summer of 2023, according to which the age of the universe could be 26.7 billion years or even more. His calculations are based on new discoveries, Zwicky's ideas about tired light, and variations in cosmic constants. The design has already been tested and agreed upon. However, this does not mean that Gupta has discovered the truth. We will only learn it through observation. Imagine if James Webb still shows us older galaxies, and even more incredible things. We may soon peer back 14 billion years and see a universe that looks exactly like today. This would mean that the Big Bang was even further in the past, or even that it never happened at all. What is certain is that all new discoveries from real observations lead us a step forward. Nearly 100 years of observations, such as black holes and galaxy dynamics, have mostly confirmed old physics, but now everything is different, and the era of shocks has begun. Our physics is stuck on several levels, and this could be the key to solving the puzzle. But something is still not right. This uncertainty puts us at a crossroads, whether to accept space is expanding or to reconsider our fundamental notions about the universe. Research and further observations, such as those conducted by James Webb, help us step by step to understand this mystery. There are various hypotheses and theories proposed by scientists about the nature of the universe and its possible future. Some talk about the cyclicality of the universe, where it periodically contracts and then expands again. Others claim that we live in a multidimensional world, where parallel universes coexist with ours. All these theories and hypotheses, although carriers of potential truth, require further research and confirmation. Each new discovery and observation help us expand the boundaries of our understanding of space and our place in it. Thus, James Webb and other space missions become not only tools for exploring space, but also windows into our own knowledge and imagination. After all, the more we learn about the universe, the more questions arise, and the more opportunities for new discoveries appear. Little is known, but physics today stands on the brink of the impossible in all dimensions. In astrophysics, we have reached limits with the study of these galaxies and the oldest supermassive black holes. In the world of microscopic particles, we also face barriers when the tiniest particles become so unpredictable that we can no longer understand them. Researchers studying the structure of cosmic scales also encounter difficulties. The more we delve into it, the less patterns and structures correspond to our notions of the Big Bang and expansion. But what does this mean? We stand on the threshold of new discoveries in the micro and macro world, as well as in the early stages of our universe. It is known that the physics of macroscopic objects is incompatible with quantum physics. But quantum phenomena are fundamental to stars, planets, and galaxies. The mismatch between these disciplines does not indicate errors in our universe, but rather that we still do not understand where and in what these differences lie. The current crisis opens up huge opportunities for scientific research. However, some influential figures in astrophysics will have to reconsider their positions. It is disturbing that scientists still argue about theories never confirmed by observations. No one has ever seen the Big Bang or the expansion of the universe. Now, thanks to James Webb, we are approaching the truth, and it is impressive that scientists continue to defend their outdated theories. This situation is reminiscent of the Middle Ages, when Galileo Galilei was imprisoned by the Church for his observations about the rotation of the Earth around the Sun. But there is also good news. Young scientists, such as Rowan Naidu from Harvard University, welcome new discoveries. In the scientific community of young astronomers and cosmologists, there is room for those who are open to new ideas and not satisfied with old explanations. Naidu, using his algorithm, discovered one of the oldest galaxies in an image taken by James Webb. The Galaxy 13 galaxy turned out to be about 13.6 billion years old, contradicting existing theories and raising many questions. The discovery heralded a crisis. Doubts were raised about redshift, and James Webb's technology was put to the test. The confirmation of the galaxy occurred repeatedly, and the James Webb Telescope is shaking up the field of astrophysics. Michio Kaku, one of the most prominent astronomers in the United States, is excited about the results. Kaku is one of the few who seriously attempts to merge quantum physics and astrophysics, and his conclusions state, James Webb finally shatters the inconsistent maps of astrophysics. No one expected such a shakeup, as many of the old scientists firmly believed that James Webb would confirm their theories. Whether science will reach a consensus or not, it must. For the universe does not lie. Currently, numerous new discoveries and research are going through the peer review process, where scientists present their findings for assessment by other specialists in the field. This helps identify possible errors, and reviews often lead to new developments and ideas. We can be assured that future research will be more thorough in presenting what they purport as truth. Doubts about the theory of the Big Bang 13.8 billion years ago deserve attention. Sir Roger Penrose, a British astrophysicist and Nobel laureate, warns in light of new data about the necessity to revert to the point where we have reliable data and observations. This means that all theories based on the existence of dark matter must be rejected, as we have no confirmation of its reality. It also means that all preceding cosmology will be completely re-examined. Let's take a moment to focus on yet another entirely new, but slightly less noticeable star in the astronomy night sky. Euclid was sent into space in 2023, and its main task is to create the best map of the universe known to us. James Webb focuses on specific objects, galaxies, planets, etc. While Euclid operates differently, it scans wide areas of space and compiles maps of everything visible from Earth. These new data should confirm the existence of dark matter and also explore the dynamics of hypothetical dark energy or not, if the research does not find evidence of their existence in Euclid's data. This will be a serious test for all those scientists who believe in the existence of these two variables. Keep an eye out for updates. The best videos are yet to come.